So let's look at now Newton's second law. We had looked at first law, then let's look at second. For those who can remember, if I can ask, what does the Newton's second law states? The Newton's second law states that the rate of change of momentum is directly proportional to the force applied and takes place in the direction of the applied force. But for us, for the purpose of simplicity of our analysis, we can also as well state it as we can say, when a force acts on a body and it's said to move, then the acceleration is directly proportional to the force and inversely proportional to the mass of the, okay? So we are saying that if you happen to apply force and your force also happen to move the body, okay, what is very true is that the rate at which you will move the body will depend on how much force you apply. In other words, the bigger the force, the bigger the rate of acceleration or increase in velocity with respect to time. That if the force is too much, even you make the body move very fast. And also, it is inversely proportional to, acceleration is inversely proportional to the mass of the body. In that when the body is too big, acceleration will be too down. And if the body is too small, acceleration is that's what we're saying, that acceleration will be inversely proportional to mass, but directly proportional to the force. The bigger the force, the bigger acceleration. The smaller the force, the smaller the acceleration. It's like when we give you a body and say, pull this. How much you move with the body will depend on the mass. That if the body is too big, you'll move with it slowly. If it is too small, you'll move with it very fast. That is acceleration with respect to mass. And the same thing to force. If mass is a constant, if the force is too much, you'll move with it so fast. If the force is not all that much, you'll move with it slowly. That one also helps us to derive the idea of second law. Remember, we stated the second law as the rate of change of momentum is directly proportional to the force applied and takes place in the direction of the applied force. That is just for the purpose of us understanding the law. But we are not going to examine it here. We are only going to derive an important equation, just that we shall use time and again. So, I can say, if A is the acceleration, okay, comma, and then M, mass of the body. Finally, if I say now, I say F, force applied on the body, our statement mathematically, okay, mathematically, if you analyze our idea, you will realize that we're saying that acceleration is directly proportional to the force. Acceleration is directly proportional to force, and they're also saying that acceleration is inversely proportional to the mass. Is that okay? And if I combine the two terms, it means A is F out of M. Is that clear? And that will mean that F is directly proportional to MA. And then I can say F equaling to K MA. And then when we say from the definition of a Newton, we said a Newton is a force which causes acceleration of 1 meters per second squared on a body of mass 1 kilogram. So that means that a Newton, which is 1 Newton, is equal to a force that will cause acceleration of 1 meters per second squared for a body of mass 1 kilogram. So when I put here, I'll say 1 equaling to K into 1 times 1, implying that K is equaling to 1. So I'll say F equaling to 1 into MA, and F equaling to MA. That is the equation we are going to be using day and night. So we started it from acceleration being directly proportional to F, and the acceleration being inversely to that, and I combined the two equations to bring that. I cross multiplied and F became directly proportional to MA. Introduced the constant of proportionality. And now I said that from our definition of a Newton, which is the force which causes acceleration of 1 meters per second squared on a body of 1 kilogram. So a Newton is 1 Newton is equal to a force that will cause acceleration of 1 meters per second squared on a body of mass 1 kilogram. So that means that if I put here F is 1, M is 1, A is 1, that means K is also 1. So if I put it back, it gives me this equation here. Then let's look at some example here. Some simple example. This equation is very, very important that we shall always use it time and again. That whenever a force acts on a body and it says to move, that resultant force will always be equal to MA, or what we are calling it accelerating force. Let's look at an example here. A force of 10 Newton acts upon a body of mass 5 kilogram. Find the acceleration of the body. Okay? That if we have a force of 10 Newton acts upon a body of mass 5 kilogram, which acceleration do you think it will cause? So we are saying that you've given me F as 10 Newtons and you've given me mass as 5 kilograms. And then using my prominent equation here, that F equaling to MA, I'll say F is 10 equaling to M, which is 5 times A. Divide by 5, divide by 5. A equaling to 2 meters per second. So therefore, the acceleration is 2 meters per second squared. Okay? That is how we can, maybe using a simple expression, we can solve such a kind of problem in that format. Let's now meet in the next example number 2.